Hi everyone, this is Tom. Today I will show you how I designed and implemented an application-to-application chat using real-time notifications. This is the short version, so let's get started. Let's go through my high-level architecture. On the right side of my diagram, I have my cloud technologies. I use Azure Web PubSub service that facilitates the communications between the publishers and subscribers. Below it, I have my web service API that will handle communications from applications and will manage storing messages. On the left of the diagram, I have two users running their chat application. When each application starts, it'll subscribe for notifications from the Azure Web PubSub. Then each app will be ready to get messages. My app can retrieve messages from the DB using the web API, and it can send messages. I'll start my demo with two instances of my client application. The top instance will function as if it's running for a user named Tom, simulating the experience and actions specific to that user. It'll send messages to Bob. Below it is my second instance that will function as if it's running for a user named Bob. It'll send messages to Tom. The first thing I need to do is subscribe for notifications. You'll see this instance successfully subscribed to Web PubSub notifications. Now I'll do the same for Bob's application. Again, you can see this application is now subscribed to get notifications. I'll send a message to Bob. Tom's app ended up sending that message via my web API. Bob's app received a PubSub notification with that message. Bob replies, and we can see that message was sent via my web API and Tom's app received it. To make it more interesting, I added a new instance that'll handle messages from Tom to a different user named John. Again, I have to subscribe with Azure Web PubSub. To demonstrate that the messages are indeed stored in the database, once my app subscribes, I make a call to the web API to retrieve all messages sent or received by Tom. Now I'll send a message to John. John doesn't have an app running yet, but Tom's first instance was notified and downloaded that message in order to stay in sync. Now let's loop in John. Once John subscribes, his application downloads all missed messages via my web API. And now John can reply to Tom. We see this message was sent. Both of Tom's instances got the notification message and are in sync. Bob will send another message to Tom, and again, both of Tom's instances receive it. Next, I'll show a chat between John and Bob. After subscribing, John's messages are synchronized. John's message to Bob was sent successfully. John's first instance is synchronized. And we can see Bob received the message. Now I'll create a third instance for Tom, which gets all past messages. My design supports sending notification messages only to that user's other instances. I achieved this by having a different hub for each user's application instances. This creates a separate private communication group that can support various types of notifications without interfering with the user chat. I found this design simplified my notification processing logic by allowing me to have a different message structure for two slightly different scenarios. Bob says, "This is cool." Yes, it is. I hope you enjoyed watching this video and learning a few things about real-time notifications. I think my biggest challenge wasn't even with cloud technologies, but trying to figure out how to run multiple application instances on my PC to simplify my demo. I think it took a few years for Microsoft Teams product to do the same, so I feel good. But I'm glad they finally support multiple chat windows. Thanks for watching.